Hello, everybody. I will start today's another live coding session. So today's of this question: Alien dictionary. So there is a new alien language that uses an English alphabet. However, the order of the letters is unknown to you. You were given a list strings words from the alien language dictionary. Now it is claimed that the strings in words are sorted lexicographically by the rules of this new language. If this claim is incorrect and the given arrangement of string in words cannot correspond to any order of the letters, return empty string. Claim is incorrect and the given letter arrangement of string in words cannot correspond to any order of the letters, return. Otherwise, return a string of the unique letters in the new alien language sorted in lexicographically increasing order by the new language's rules. If there are multiple solutions, return any of them. I see. So let me clarify my understanding first. So basically, the question statement says there is a new language and it uses the English alphabet only. And it can be lowercase English letters only. And the order of the letters is unknown to you. Maybe it is A, C, B, Z, blah, blah, blah. Yeah. And also I'm given the list, no, and I given the list of words like this. So the alien, jets that this is sorted. But if there is a contradiction, like let's say this dictionary has A, B, C, and also it has B, A, C. In this case, the order of A and B is not unclear, ambiguous, and there is a contradiction here. So I should return empty string. Otherwise, let's say I'm given like this. In this case, the order should be BAC, something, something, and C. So it just returns the whole concatenated string. But of course, there is a case that I'm given something like this. Yep. Okay, so that's my understanding of this question. Good. Aside from that, as I can see, words consist only of lowercase English letters. So I can say something like this. Okay. Yep. So that being said, I will think of the algorithm. So let's say I have ABC and CBA. So what I can do is compare, let's say something like this, each adjacent pair like this, and then this, and I learn something from this. So if ABC and CBA, if in this order, I can say, I compare ABC and CBA, and I can say A is before C. And it doesn't matter what characters follows after that. After that, this AC pair. So if I have two strings, and if they say they are sorted already, I can compare these two strings. And if I find AB, they're the same. This is a tie, so I have to take a look at the next character. Yep. Then here, B, D, they're different. So I can say B is before D. And that's it. I don't have to take a look at following characters anymore. But some edge case I have to think is something like this. Or maybe completely tie, or maybe something like this. In this case, if this case appears, I can immediately return empty string because this is already the contradiction. So in this case, sorted lexicographically. Yeah, in this case, it's okay. I learn nothing from here. Yeah. Then in this case, I don't learn anything here too. Because this is, yeah, no matter how the English letters are ordered in the alien world, this is met. Okay, so now I can say, in a high level, what I will do is compare each adjacent pair and I learn something. Then I will continue this. And if there's contradiction, sorry, I will return empty string. Okay. And in the end, build ordered charts, string, and return. Okay. So when I learn something like B before T, probably I can get it ordered as the graph. Yep. So when I learn B to D, yes, I can put it here. B to C, yes, I will put it here. Let's say next I learn C to D. The graph looks like this. So in the end, sorry, there may be some contradiction. Like, let's say I get C to B. In this case, invalid. And let's say I have another, order like D to X. And if I got X to B, then it invalid. So let's use the graph. Let's use the adjacency graph. So I can say X to Y edge, put this to adjacency graph. Then if there's a contradiction here, I can use the DFS. So yeah, no, maybe from Y. I do DFS from Y and find X. If I can find X, it means that there's a contradiction because how should I say? X is in the downstream of Y in the given graph, but in the new learning, this isn't true. Oh, let's say, obviously I should check the contradiction first and then put this XY to adjacency. Okay, this is it. Now let me get started with the implementation. Oh, I will do the complex analysis. Sorry. So for time complexity, I can say I will take a look at each adjacent words. So let's say there are n words, and the length of each word is L on average. In that case, I have to compare n words, n adjacent pairs, and for each there are L characters. I use the 2 pointers. So wait me. For each n, each pair, firstly I check and learn something. Then in line 37, I check the contradiction. So it will take. So I have the graph, and I have to, in the worst case, I have to traverse all the adjacency. All the edges in the adjacency list to find that, you know, um, find X. All the, nodes and all the edges. So, so in total, it should be 26 characters plus n, which is the number of edges appeared before, which is at max n, because I've checked n pairs. So this is a time complexity, which is nl plus n squared. Maybe I can say this. Okay, for space complexity, all I need is the adjacency list. Yep. So this adjacency list has 26 nodes and n edges in the first case, because I learn one edge from each pair. So, and I do n pair checks. So it should be n. So in total n. Okay. Good. Now let me implement the frequency implementation. So first thing I do is compare and learn something. So here I compare I plus I1, I plus 1. The I and I plus 1. So what can I do? So def so validate order, maybe. Not validation. Check order. Word 1 and word 2. And I return tuple or none if there is nothing to be learned. So in this way, I call it in this way. Now, this can be none. So if chair order is none, I don't learn anything. So here, I get the order. Then what I will do is line 37. Validate order. So I need the adjacency list. of the chairs. And I pass adjacency list and chair 1 and chair 2. And if there's a contradiction, I return false. So if this is false, I return empty string immediately. Otherwise, the validation passed. So in line 38, I put XY adjacency graph. Okay. So now I've done 38. So in 39, I return it. Oh, here I have to build the orders in a string. Wait, so it doesn't guarantee that all the characters appear in the words. In that case, what should I do? It says if there are multiple solutions, return any of them. So sorry. If I get only A, B, and BA words, then only A and only B, A, B order is found, but others are not found. So I can return anything like ABC or maybe CBA. Yeah. Yep. So this is it. So my task is to implement the helper methods. So let me start with check order. So let's say, sorry. So let's say the ranks of the mini. Oh, sorry. Let's say I have A, B, C, and A, B, D, X. That case. For the mini ranks of each, I take a look at this. And if the chairs are the same, I continue. But if they're not the same, yes, I've learned something. So I return this one. Oh, okay. I don't need it. By the way, I noticed something. But let me tell it later. So in the end, I've checked under this here. So there's the same. So in this case, there, as I said, two cases. There can be contradiction here. ABCD and ABC case. So, what should I do? Nom, what should I return here? Maybe I should raise an error and catch it, but I think it over too much. So If I learn nothing, I will return. Okay, so I will return tuple of tuple. Oh no, sorry. So yeah. Here, first one, this is the order. Here, this is Boolean. Here, none if there is nothing new to learn. So here in this case, I return true because I've found something. There's no contradiction. Yeah. Here, then let's say if length of the word one is longer, there's a contradiction. So I should return non-false. Otherwise, I should return none but true. There's no contradiction. Okay. So here, if contradiction, I return empty string immediately. Otherwise, I learn something from char order. Yeah, so good. Okay, so now I've done with the check order implementation. Now we'll do the validate order implementation. So start from need adjacency rest. So I'm expecting that C2 is under, downstream of C1. So check do DFS from C2 to find C1. If found, return true. So this is it. Yeah. By the way, if C1 is equal to C2, oh, it cannot happen. Yeah. Okay. And I will do this validation here also. Okay, so I do the DFS. So, and obviously I have needs the scene set so that I don't visit it the same place twice. Theoretically, I don't need it because it means that there's a contradiction. And in that case, it already returned, the empty string is returned from this main method and the process is already done. So I don't have to take care of the scene set. So here, if current is equal to C1, I return true. Yep. Otherwise, I append C1, no current here. Okay. Then in the end, I return false because, no contradiction in the end. Yep. Okay, good. Now let me implement the build order string. So let's say I have the graph something like this. So in this case, I should return something like ABDC or ADBC. Yep. and maybe E, F, G, blah, blah, blah. And also, or A, D, B, C, then E, F, G, blah, blah, blah. Yeah. Or maybe, obviously, I can change this order, C, E, F, G, C, E, F, G, no, sorry, E, F, G part. So maybe that's also possible. Yep. So that being said, I do the DFS from the first node. What's the first node? So if there's a, I think I have to do the topological sort here. So I have to check the in degree, and if in degree is 0, I can start from there. Otherwise, I have to pick another node because there is an upstream node character. So maybe women. Does it really work? Yeah, I think it works. Okay. So you know the degree for the adjacent series, so C1 to C2. Mm-mm. For this, now I get C1, like A and B, so B should be incremented. The third degree, I should do a default dect int. So third degree C2 plus equal 1. Yeah. In this way, I've got the in degrees mapping. So from here, I check, I do the topological sorting. I can do it in this way. So here I guess each character from A to Z. Then if third in degree, I mean, this third in degree is not 0, I skip it. Because there is some other node, so some other character which comes before this character. And in that term, I do DFS here. So this char is visited. So, so I start DFS from here. Wait, is it okay? I do DFS from here. Let's say I do A, B, C. In that case, I didn't visit D. That's a problem. I think I just can move this A to B. No. So I have to do, I mean, from this character, I have to visit all the adjacent characters. It's more like BFS in a sense. So I append this char to order chairs. Yeah, here. Then maybe this is it. So okay, so wait, maybe I have to think of the algorithm more. So if I'm given the adjacency width, I have to get the order, which means all the orders given. So definitely this is the typical, topological sorting. So yeah, I think this is good. So wait a minute, is this already visited? I see. Okay, okay. So let me use this tag to keep track of the chairs I can visit. So yeah. Sorry. So to be honest, now I remember what to do. I don't have to make a stack visitable chairs. So here, for each char, what is all the chars? Ah, I see. So, okay, so for each char, if char degree is equal to 0, this is visitable. I append this char. Otherwise, this is not visitable, so I don't do anything. Okay. Now I've got visitable chars. So I get the char and append it to the ordered chars. Then from this char, I take a look at each adjacent chars. So what I should do is decrement the in degree. So if this is 0, sorry, I append this adjacency char to visitable chars. This happens only once for each char. Okay, so now I've visited all the chars. So I return the string built from these ordered chars. Okay, this is it. So I actually don't have so much time today, so let me immediately execute my code. So for ZX, seems like the contradiction is, maybe detected. I don't know, but printed out here. Yeah, contradiction is detected earlier. So no, 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 because I know. I mean, I see. So here, return false is just contradiction. So this is no contradiction. So I have to flip it. I should say self dot. So still always it returning empty string. Yeah. So in 0 to 0, 1, sorry, index 0 and 1, index 0 and index 1 pair, there's contradiction. So what I'm saying is check order here. This logic is wrong. Mm. If length word 1 is longer than length word 2. So what do you mean? So what return here? No contradiction true and T to F. Yeah, this is correct. So I go to line 77. Char order is this one. Difference on C to yes. Validate order. Return false if there's contradiction. So what return here? False. So it says there's some, you know, um, contradiction here. So, but there shouldn't be because it has no, you know, um, graph yet. The graph is empty still. So, oh, I should start from C2. So C2 is here. Adjacency, this should be empty. I mean, no for loop here, and I go to line 119 and return false. No, so I should return true here because there's contradiction, and false here because it's the contradiction. Okay. I think I'm almost there. Wait. Oh, I don't have to return. Yeah, all the characters. I see. So, okay. If the character doesn't appear into any word, I can say that word isn't, the character doesn't exist in the alien dictionary. So maybe the problem is here. So instead of doing this, and if in degree is 0, I append it to visible chars. In this way, non-existent character is popped out. Maybe no. Now chart in degree looks like, yeah, this. Indeed, all the character has in degree 1. How about this one? In this case, seems okay. Ah, I see. So in degree, okay. This cannot be all the characters, all the, yeah, character key. So I have to check in this way because this is the default dict, and if the key is not called, it doesn't exist. So what happens now? Okay, so now let me take a look at the case 2. Here, chart degree in degree is here, so x to 1. And why z is not included? I see. So seems like I need the width. No. Okay, I see. Chart in degree. Okay. So at least I have to check all the characters in the adjacency list, maybe? No. How can I get the list of all the characters appear in the given string? Maybe I have to make it up. Anyway, in that way, I make it up. And then for each character, check the in degree. And if it's 0, it's visible. Mm. Yeah, so my task is to find Z, include the Z into this visible chars. Okay. Maybe I can say all chars list here. So with this all chars list, I do each char, and if in degree is 0, I append it to the visible chars. Okay, so now I will create this all chars set. Here, okay, now I build the all chars set, so I pass it. Okay, let me try with this again. Good, now accepted. Okay, so let me comment out the print statement, and I submit again. Okay, good. So I can solve this question. So let me quickly wrap up. So today I solved the question named Alien Dictionary. So in this question, I'm given the list of words, and words are sorted according to the words are sorted in the alien's word. So in this alien's word, it uses the English lowercase characters, and yeah, the same way as this word, but the order of the chars are different. The order of char is different. So from the given words list, I find out the order of the chars in the alien word. Then I should return all the characters in the alien word in a sorted way. Yeah. So the basic approach is For the given list of words, I take a look at each adjacent pair and learn something, some order of the chairs. Yeah. And if there is a contradiction with the chair orders I learned already, then I should return false. No empty string. But otherwise, I append the new learning order, new order I learned into the adjacency graph. And then in the end, I have the adjacency list, the adjacency graph. So I build the chairs in an ordered way. I mean, I sort the chairs in an ordered way and return the concatenated string. So in my case, the mistakes I've made are the flag I returned from check order method and validate order method. So I was confused by this part. Yeah. And also build ordered string. I had to do the topological sort, but I took a bit time to implement the topological sort. Maybe it was out of my memory. So I should, remember that again. And also the, kind of mistake I made, or I should say, the kind of thing I should have clarified first is here. Each word, consists of lowercase a to z, but it doesn't necessarily all the characters. Maybe z doesn't appear in any word in the words list. In that case, I shouldn't include this z in the returned list. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.